Hey guys, welcome back to the channel. In a previous lecture, we understood about the theory of recurrent neural networks, which is RNN. Now, in today's particular video, we are going to implement our first NLP model by using recurrent neural networks. So, let's get started. So, here we are going to implement tweets analysis by using recurrent neural networks, in which we are going to implement whether a tweet is positive or a negative, which is a part of sentiment analysis, right? So first of all, you can see here I have imported pandas library. As you might know about that, pandas library is mainly useful for importing any kind of data set using Python. And here we are going to use read_csv function to implement our dataset reviews.csv. And by using head function, we can see first 5 records of our dataset. Here there are mainly 3 columns in our dataset: ID, label and tweets, right? Here you can see there are 31,962 records, right? So here what we are going to do, we use the tweets as a input and we can use label as a output for our training purpose. And finally we trained our RNN model, and after that we can predict whether a tweet is positive or a negative. Suppose if we got the output is 0, then obviously that tweet is negative, and when we get the output as a 1, then it is positive. So here you can see there are mainly 2 values of label, 0 and 1. 1 means negative and 0 means negative and 1 means positive. So by using unique function, you can see the unique or a distinct value of particular column, right? Here I have checked, is there any null value available in our dataset or not. So by using isNull.sum function, we can come to know that is there any null value available or not. So here you can see there is no null value available in our datasets. Guys, after that I stored all the tweets in variable X and all the labels in variable Y. Right now the main part is coming, which is data splitting. So in each and every model in machine learning or a deep learning, we have to split our data sets for a training and testing, right? So that we can evaluate our model and we can predict or we can test whether a model is accurately performed or not, right? So by using train test split function, which is implies in sklearn library, sklearn.model selection, we just need to import train_test_split so that we can split our dataset into 2 parts. So here in the first argument I just need to put X, in a second argument Y. X means our tweets, Y means our label, and the third argument is which is test size. So I put 0.1, which means I split the data into ratio of 9:1. So 90% data can be used for the training and 10% data can be used for the testing, right? And shuffle is equal to true, means it shuffles all the data set, right, randomly. Now we got the 4 values in return by using train test split. So first value is X train, which is 90% of our tweets in our data sets. X test consists 10% data or tweets in our data sets. Y train consists 10% of our 90% of our labels, and Y test consists 10% of our label, right? So here we are going to use X train and Y train, which consists 90% of data in our training, and X test and Y test can be used for the prediction, or we can say evaluate our model. Right, now you can see the shape of our training data set is 28,765 records, and for the test it consists 3,197 records. Right, now the second step would be we need to make a vocabulary. As you know, we have to convert every tweets into the numerical form. Right, if you don't know, then please watch out my feature extraction techniques that can be a very useful to understand this every concept. Right, I have explained every feature extraction techniques, which includes bag of words, TF-IDF and word embedding. Here in this particular case we use the word embedding techniques. Right, so for that our purpose is to convert each and every tweets which is in a text form, we have to convert into a numerical form. So for that we have to first make a vocabulary of unique data of entire our data sets. So for that we just need to import tokenizer split each and every sentence into a list which consists the each and every word as a list value. Right, so here I put vocabulary size 500 and this OOVE dot TOK token, which means if is there any words that are not available in our vocabulary that can be replaced to the OOVE. Here you might be thinking that why I am customly or manually defined 500 vocabulary size. So because when we find the distinct value of our data set or distinct words in our data sets, as you know our data set size is 32,000 approximately. Right, so it might be many unique values. Right, approximately 1 lakh. Right, so there we need to very high configuration to handle that kind of vocab. So here as of now I just use the only 500 vocab data. Right, and rest of will be replaced to this value OOV. Right, now here I just use the tokenizer in which number of words which is the vocabulary size. If you don't want to define the manually vocabulary size, then you can also use the all the vocabulary data, which means all the unique words that are available in particular data set. Yes, obvious that if you use the all the vocab data, then your result is always be accurate. Right, because suppose you use the 50,000 words. Right, and here I have used only 500 words, so obvious that model can come to know many words while training. Right, as compared to my vocab size, so obvious that model perform well. Right, and here unknown tokens I took this value. Right, now after we need to fit the tokenizer to the value. So here I just want that X train. As you know, X train consists entire 90% of tweets. Right, after that you can see all the vocabulary data by using word underscore index function. Right, so here you can see entire vocabulary which is consists 500 unique words. Right, rest of will be replaced with this OOV ID. Right, after that we convert entire text sentences into a numerical vector by using our vocabulary. So for that we use the text underscore to underscore sequence, and we just pass the X train. So here you can see our 10 records will converted into this numerical vector. Here you can see vectorization of this particular tweets. Right, After that, we have to include the padding. Padding means we have to equal each and every tweets with the same length, right? So for that, we just need to perform the padding. For the padding, we use here pad underscore sequence function, which implies tensorflow.keras.preprocessing.sequence, right? Here also you can use the max length by maximum length of the tweet, right? But here, as I already told you, that we need to high configuration. Suppose the length of maximum length of tweets in our dataset is suppose 1000, then we have to convert each and every tweet by lengthy 1000 by using the add padding at the last, right? But here I just manually put the length is 100, so each and every tweets will be equal length of hundreds. If any tweets contain more than 100 words, then it should be cut after 100 word, right? So here just use the pad underscore sequence, here train underscore sequence, which is our numerical vector of entire tweets, and just pass the maximum length, which is 100. So here you can see the length of sentence 0, or we can say tweets 0 is 15, but after padding it's converted into a 100 length. You can see here it default use pre-padding, which means it use 0, it put 0 at the beginning, and after that we can see the actual vector of that particular tweet, right? The same thing we have to apply for the validation, or we can say our 10% data. So for that we just use x underscore text, right? The entire code is same. Here you can see our records is 3197, and we just converted into entire 3000, approximately 3000 records into 100 length, right? Now the main part is coming, which is building a model architecture. So here we are going to use TensorFlow library, which is quite popular for the model building. There are two main libraries are available for building a models in machine learning. The first one is TensorFlow and second one is PyTorch. But here we are use the TensorFlow library, which is quite popular, as well as the very user friendly, easy to implement for the beginners, right? So here we just import TensorFlow as a TF. Now here I mentioned the embedding dimension, which is 64. So this is the feature extraction technique, right? As we already discussed in our previous video about the word embedding, how word embedding is going to be a work and what is the importance of word embedding. So if you haven't watched yet, then please watch out first about the word embedding, then come to start this video, right? So here we are going to use feature extraction technique and put the dimension is 64. So TensorFlow has a facility of word embedding, as it consists word embedding as a layer. So we don't use any third-party libraries like Word2Vec or a Glow for this word embedding part. So here for the model building, first of all we use the sequentially, as our model should be a sequentially line by line linearly. The first layer is embedding, which is consists our word embedding part, which is feature extraction part. So it entire layer, or we can say all the layers are available in tf.keras.layers, right? The first part is vocab size, which is our 500, and embedding dimension is 64. Now here the layer called simple RNN, which consists our RNN architecture in TensorFlow, right? So we use tf.keras.layers.simple RNN. Here we use the 64 nodes, right? These nodes, as we call as a hyperparameter, it can be anything, right? You can use 64, 128, 256, right? It is based on trial and error. And here we can use the activation function as a ReLU. If you don't know about this deep learning concept, then first of all you have to learn about the basic deep learning and how neural network is works, right? After that, we use the dense layer. Dense layer is nothing but the fully connected hidden layer, right, which consists 32 nodes, and here also we use the ReLU function, and at the last we use the dense layer and with a one node, and here I use the sigmoid activation function. So as you know, sigmoid gives the output between 0 to 1, so it has a threshold of 0.5, right? So if the value comes upper of 0.5, suppose 0.7, then it will be rely on the 1. 1 means it is a positive sentence, and if output comes suppose below the 0.5, which means the 0.3 for example, so it can be considered as a negative. So that is why we use here only one node, as we only want the one output. So by using the model.summary function, you can see the architecture of our model. So here you can see the first layer is embedding, then simple RNN, then dense layer, then our output layer, right? Here you can see the shape. None means it can be calculated, right? And the total parameters according to our input, right? So total parameters are going to be trained is 42,369. Now we have to specify our loss function, optimizer, and matrices, right? So what is loss function? So loss function is basically tell us that how our model is performing after each iteration. Here iteration means each epoch, right? It can tell how many errors are there in our model after the each iteration, and the optimizer try to rectify, try to accurate our model after the each iteration. So here I have used the binary cross entropy as a loss and Adam optimizer as a optimizer, and matrices means I put the accuracy here, which means I come to know all the values after the each iteration. So here I have put accuracy, which means I got the loss, accuracy, validation loss, and validation accuracy after the each epoch, or we can say iteration, right? Here the number of epochs I put 5, right? And by using the fit function, we just train our entire model. Here our X is train padded, which is equal length of our sentences, or we can say tweets, and Y train means our label. Epochs consider number of epochs, and validation consists our validation, which is our 10% data, and entire train model into a history variables. So here you can see each epoch. Suppose here in a first epoch we got the loss is 0.90, right, which means 0.19 is a error available after the first epoch, right? We got the 93% accuracy, the validation loss is 0.15, and the validation accuracy is around 94. Likewise, you can tally model accuracy and the model loss after the each epoch by specifying this matrices, right? Here I have put the accuracy and loss graph. Here you can see our accuracy is going to be higher as we want after the each epoch, right? After the each epoch our accuracy is going to be high. However, our validation accuracy can be zigzag. Here you can see after the in a third epoch we got the lowest accuracy, and then also after that it rise, right? Now here you can see our loss is continuously decreasing as we want, right? So what we want, after the each epoch our accuracy should be increasing and our loss should be decreasing. If this is happen, then your model is going to be a well trained, right? And in our case you can see our accuracy is rising and our loss is decreasing, that means our model is performing well, right? However, there should be a many inaccuracy though, because of our validation accuracy. You can see our validation loss is quite stable, and our validation accuracy is also quite zigzag. So I think you can train more time, suppose 50 epoch or we can say 100 epoch, that might be good, get a good result, right? Now here for the prediction, here you can see I just used I like my laptop but it's hanged, right? So here the sentence. So first of all I have to convert it into the numerical form by text underscore to underscore sequence. After that I need to perform the padding for the equal our sentence length by the trainable tweets. So our trainable tweets are the padded with the 100, which means the size of every tweets uh, was 100. That is why I have to convert this padded into a 100, right? Here -1 implies that as you know 0 is start to from 0, so that is why we just need to stop at 99, right? The prediction, so model dot predict, here we got the padded value, and here I have told that if it is greater than 0.5 then it should be a positive, or if it is below 0.5 then it should be a negative. Here I just converted type into a integer 32 bytes, right? And here you can see if it is come to 0 then we got the negative, or it is positive. So here you can see our output is negative. We got the two-dimensional array here by printing the predict. If you find this video informative and if you learn something new from this video, then please hit the like button, share this video to your friends who also want to learn NLP or machine learning, and subscribe this channel. Thank you.